In this lesson, we're going to talk about dealing with exponents. So first, let's start off with a definition of what do we mean by an exponent. So if n greater than 0 is an integer, then the expression a raised to the n power means a times dot 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 a n times. We just multiply a by itself n times. The expression a to the negative n means 1 divided by a raised to the n power, and then a to the 0 power is defined to be 1. The letter a is what we call the base. Now that base does not have to be a number. It could be a number, or it could be an expression, it could be a variable, it could be a lot of things. And then the number n is called the exponent. Now here we summarize 5 important laws of exponents. The first one says that if we multiply like bases, we simply add the exponents. The second one says if we take a power and raise it to a power, we simply multiply the two powers. The third one says that we can distribute powers across multiplication. So here we have two bases, a and b. We're raising that to the n power. That's the same as a raised to the n times b raised to the n. The fourth is similar, but it deals with division. Here we have a divided by b raised to the n. It's a to the n divided by b to the n. And then the fifth property deals with dividing like bases. If we have like bases, we simply subtract the exponents. Now, one important property that's not there is dealing with addition. Notice that a plus b raised to the n power does not equal a to the n plus b to the n. In other words, you can't distribute powers across addition. It'd be really nice if we could, but unfortunately that doesn't work. Okay. So let's look at a few simple examples of simplifying expressions dealing with exponents. So here we're multiplying two terms. Both of them have powers. And so let's start off just by rearranging things. Let's take this 3 times 4, and then x cubed times x, and then y to the 4th power times y to the 5th power. And again, that's all justified by the commutative property. Now we can simplify things. 3 times 4 is 12. X cubed times x. Those have like bases, so we can add the exponents, x to the 4th, and then add the exponents here to get y to the 9th. So there we have a simplified equivalent algebraic expression. Here's another one where we have a term raised to the 4th power, and our third property says that we can distribute that power to each one of these terms. Okay? So what we mean by that is this is equal to 2 to the 4th power times a squared raised to the 4th power times b cubed raised to the 4th power times c raised to the 4th power. Okay? Now we can do this arithmetic. 2 to the 4th power is 2 times 2, which is 4 times 2, which is 8 times 2, which is 16. And then here we have a power to power. So we have 2 times 4, which is a to the 8th power. Another power to power. This is b to the 12th. And then c to the 4th power. So there we have simplified algebraic expression. Here's another example dealing with division. And so first of all, let's simplify this first expression by distributing the square to all the terms here. So we're going to have a 2 squared, which is 4, and then an r to the 3 times 2, which is 6, divided by s squared. And then we'll take that times s divided by r cubed. Okay? And so now we can subtract some exponents. We have r to the 6th over r cubed, so r to the 6 minus 3. And then we can take that times s to the 1st power minus 2. So this is 4r cubed times s to the minus 1. Now if we don't like dealing with negative exponents, we can write this as 4r cubed over s. And so there's our simplified algebraic expression. Here's another one dealing with exponents and division. So let's just break this up. 8 over 4, that's 2. And then x cubed minus a negative 1. Now the fact that that exponent of negative 1 in the denominator is really irrelevant. We treat it just like any other power. And then y to the negative 5 minus 2. So we have 2x to the 4th power times y to the negative 7. And we can rewrite this without negative exponents like this, 2x to the 4th over y to the 7th. And there we go. There's our simplified algebraic expression. One last example here is not simplifying but factoring. At first glance, this factor looks maybe like a difference of squares because 16 is 4 squared. Well, we can rewrite this using properties of exponents as x squared, quantity squared, minus 4 squared. That's perfectly justified by the laws of exponents. And so now we have something squared minus something else squared. And so that's a difference of squares. So I'll take my first something minus my second something times the first plus the second. But now this first term is a difference of squares. So I'll write this as x minus 2 times x plus 2 times x squared plus 4. I can't factor those first two terms anymore. Last term I can't factor either. And so there we go. Here's our simplified algebraic expression.